Kia ora Year 12 and 13. This is the first video I'm doing of this year's Level 3 Calc papers. I'm starting with complex numbers. So I'm just going to go through some of the merit and excellence questions over the next few nights while I've got some time. This one here, question 1E, I think is probably an excellence question, but I'm not sure. It might be merit. And we're given two complex numbers, W and Z, and we have to prove this thing here. So I think the key here is to do some of the work before we start substituting in and get into a big mess. I'm going to start off by just defining what W and Z are. So let W equal A plus IB, and let Z equal, what did I say, C plus ID. And A, B, C, and D are all real numbers. Okay, and we're also going to need the conjugate of Z. So Z bar is equal to C minus ID. And now I'm going to add them together. So W plus Z is equal to this plus this. So it's A plus C plus I times B plus D. And W minus Z bar, I'm going to do a little bit more slowly. So W plus IB minus C minus ID, which gives me A minus C plus I times B plus D again. Now, on the left-hand side here, we're ready to substitute in now. We're going to work through the modulus squared of those two things. So on the left-hand side, what do we have? Well, the squaring is a good thing here because it means I can just immediately undo my square root. Even though it's a proof question, I feel like it's fine to go straight to this. And then I'm going to have minus what? Minus the real part squared plus B plus D squared. Okay, so that's just applying the definition of modulus squared to those. Now that's going to give me A plus C squared plus B plus D squared minus A minus C squared minus B plus D squared, which is nice because these are going to disappear. And so is that strange plus sign sitting there. Now, all I have to do now is expand things out. So we get A squared plus 2AC plus C squared minus A squared minus 2AC plus C squared. Cleaning all of that up gives me A squared minus A squared goes, so I get 4AC. And then we just go back and have a look at where we're trying to get to. So we want to end up with 4 times the real part of W times the real part of Z. So we're just about done. Because A is the real part of W and C is the real part of Z. So that's equal to the right-hand side as required. Now, I probably could have chucked another question in this one, but I haven't got one set up yet. So that's all for tonight. I will do some more tomorrow. Thanks for watching.